Hey mathematicians, so the reason that we are going to use the method I'm getting ready to show you is that yes, you can type this into Desmos and you can see that the y-intercept is a whole number at 2, but the x-intercept is kind of halfway here in between 2 and 3. And once we get to graphing more than one equation at a time, you want it to be as precise as possible, which is why I'm showing you this particular method now. So again, the reason we're getting ready to use this strategy is because graphing by intercepts doesn't give you two integer or whole number values. So we're going to do something a little different. And that something different is that we're going to take this equation from standard form and we're going to convert it into slope-intercept form. So here we are currently in standard form, and we want to convert it to slope-intercept, which of course is y equals m, oh, that was a really ugly m, sorry about that, mx plus b. So the first thing we're going to notice is that in standard form, the x is on the left-hand side of the equation, but for slope-intercept form, we need it to be on the right side of the equation. So step 1 is that we're going to move the x to the other side of the equation. Please forgive my ridiculous, childish handwriting. So how do we get rid of a 3x? Well, the opposite of that 3x is going to be a minus 3x. So we're just going to take that 3x off the left-hand side of the equation. But just like any other equation in numbers, if you subtract 3 x's from the left-hand side, you're going to have to subtract 3 x's from the right side as well. So this will cancel. I'm going to bring down the 4y that is still remaining. And then on the right-hand side, I've got an 8 and a minus 3x. So hopefully you recall from previous lessons that you can't combine a variable and a number because they're not like terms. So we're just going to have to keep the 8 and the minus 3x as two separate terms. And because in slope-intercept form, x comes before the b, I'm going to write the minus 3x first. So minus 3x plus 8. So the first thing we did is that we moved that x over to the other side. Step 2 is that in slope-intercept form, the y is isolated. Right now, the y is not isolated, right? So we've got to isolate the y. Now, what a lot of people mistakenly think you do, and I'm going to write this in red because it's not correct. A lot of people think you need to cancel out that 4 with a minus 4. That isn't what we need to do. That 4 sitting next to the y means multiplication. So how do we cancel out multiplication? We do it with division. And we need to divide every single term by that 4. So let's see what we got left over once we get done doing that. So first of all, the 4's are going to just cancel each other out, so that you're left with that isolated y like you need it to be. I'm going to get rid of this little line here. So now we have y equals, and look at what's going to happen right here with this 3 and that 4. So 3 divided by 4 does not turn out to be a whole number. However, 3 over 4 is a simplified fraction. So I'm going to rewrite it as that 3 over 4. And I need to make sure not to forget that negative that's with it, since there's one negative there. That means it's going to be a negative 3/4 x. So that's going to become my slope. And then finally, when I do 8 divided by 4, I'm going to get my y-intercept of 2. So this is the equation in slope-intercept form. y equals negative 3/4 x plus 2. So now that I have that equation in slope-intercept form, I'm going to start with the b, my beginning point, my y-intercept. So my first coordinate is going to go right there at positive 2. And then because I've got a slope of negative 3/4, what makes the most sense to me is to go from that beginning point to go down 3 and then over to the right 4. So how does that make a negative 3/4 slope? Well, since I went down 3, that's a negative, and to the right is positive 4. So a negative and a positive does make a negative in direction, the same way that it does when you're multiplying and dividing. And remember that we need 3 coordinates if they'll fit on the graph. I don't have room to go down 3 and over 4 again this direction, so I'm going to go back to my beginning point, and I'm going to go up 3 and then to the left 4. So that, as you can see, that's a positive 3 because I went up, and then going to the left is negative because that's where your negative numbers are. So I'm still making a negative slope by going up and to the left because a negative and a positive still makes that negative slope. So then I'm just going to connect them. Remember to please give me lines that go all the way across the graph, like so. And it's not all the way mathematically correct without those arrows either. So you can see that converting this equation into slope-intercept form gave us a more precise way to graph the line because we've got those 3 dots, those 3 coordinates that we could line up.